Hello all, my name is Rahman and welcome back to my YouTube channel. So guys, in this video, I am going to start a new section known as classification. So guys, up to this point, we have been working with the regression. So in that section, we have talked about the introduction, we have talked about the features, labels, forecasting, predicting, theory, etc. But guys, in this video, I am going to begin a new section of the classification where in classification I am going to cover the two major classification algorithms known as k-nearest neighbors and support vector machines, which is also called as SVM. So while these two algorithms are both classification algorithms, they achieve the results in different ways. So guys, first of all, let's talk about what is classification in machine learning. So guys, in machine learning, classification is a supervised learning concept which basically categorize a set of data into classes. The most common classification problems in the classification are speech recognition, face detection, handwriting detection, different documents classification, etc. And now I am going to talk about the two major algorithms like, as I said you, k-nearest neighbors and SVM, support vector machines. So first of all, let's talk about the k-nearest neighbor. So the k-nearest neighbors algorithm, also known as KNN or k-NN. So KNN is non-parametric supervised learning classifier which uses proximity to make the classifications or predictions about the grouping of an individual data point. Okay, so guys, now let's talk about the support vector machines. So guys, as I have already talked about that in the previous video, like what is support vector machine. So support vector machine is a supervised machine learning algorithm used for both classification and regression. Though we say regression problems as well, it is suited for the classification. So it's suited for the regression and it's suited also for the classification. The objective of SVM, support vector machine algorithm, is to find a hyperplane in an n-dimensional space that distinctly classifies the data points. Okay, so guys, first of all, let's go ahead and get started. So guys, as you can see here on the screen, we have a graph, okay, where we have these 6 points, so in different groups. Okay, so at this place here, if you see, we have 3 dots, and in this place we have the 3 dots. Okay, now these two are groups. As you can see here, these are the groups here. So guys, when we are feeding the machine, when we are feeding the data into the machine learning algorithm, we are actually telling that these groups exists, and which data belongs to which group. We are also telling that. The similar form of machine learning, where you actually have the machine find the groups as well as these are also called as clustering. So guys, I am going to talk about the clustering later on in this series only. So now I am not going to bring the topic here. So now guys, let's come to another example, another data set here. Now if you see here, we have a data set in which we have two groups, okay, one with plus and another with minus. So guys, the group with the pluses is have the 3 plus, and the group with the minus is also have the 3 minus. Now guys, the problem here is that what if you get here a dot? What if you get here a data point? So let's wait a second now. Okay, now so guys, what if you get here a data point here, something like this? So where will you assign this data point? Will you assign this in the plus group or will you assign this in the minus group? Okay, so guys, your answer will be obviously in the plus group because this dot is closer to that group. Okay, now wait, if I will be moving this one now. Now guys, what if I have a dot here beside this one, okay, in the beside this group, minus group? So where will I assign this one? So what he say is you will assign that here only. But guys, what if I assign a dot somewhere around here? Okay, so we have these 3 bits. We are having these 3 bits. Like what if I give a data point here in the plus group and what if I give a data point in the minus group. So these two bits were easier right now. But guys, in the third bit, this is pretty much difficult for us. Like, where should we move this one? Where should we move? In which group should we move this, right? So guys, in this case here, we have to use here the k nearest neighbors algorithm. So guys, k nearest neighbors is a simple and effective machine learning classification algorithm overall. So if this is so easy saying, as we just saw, why do we need an algorithm as opposed to just looking at the data sets? Like, we can say that in this case we can give here the data point here and we can that. But guys, what if you have here? So in this case, as I said we can use here the algorithm known as k nearest neighbors. So guys, just we learn with the regression, machines can both also calculate much faster, working on the larger data sets, scale, and maybe one of the most importantly, working in many dimensions such as 100, etc. So now guys, let's come to another data set here. So guys, as you can see here, in this case here, I have another data sets where we have the 3 plus in the red color and 3 dots. Let's use the dots in the black color, and here I have a dot data point. Okay, so guys, the way it works completely in the name. So as I said there is a formula, there is an algorithm known as k nearest neighbors. So that is k nearest neighbors. Okay, so anyhow guys, now I'm not going to type that all of those things because it's going to waste a lot of time on the video. So anyhow guys, as I said the algorithm is k equals k nearest neighbors. Now the way it works completely is in the name k. Let's say k is a number that you can choose. Like, if I choose a number like k equals to 1, 2, 3 anyhow. Okay, now and then the neighbors at the data points from the known data are that we are looking for any number of the nearest neighbors. Okay, so guys, I am going to remove this. Sorry, this one. Okay, in this case here, let's use it. Okay, so anyhow guys, now I am going to create a variable. Now let's use here this one. Okay, now let's say that k equals to 3. So k should be equals to 3 actually. Okay, so let's say k equals to 3. Then we are looking for the 2 closest neighbors points, for example. Okay, as I said k equals to 3. So then we are looking for the 2 closest neighbors points for the example. So if you see here with this dot, we have the 2 here. These 2 are the nearest in this case. So these are long. If you use the ruler and find the distance, then this is the nearest. So guys, in this case, if you see here, in this case, all 3 are with the plus class. Okay, so in this group, in this case here, all 3, this plus group is with the data point, this green data point. So here, as I said, k equals to 3. Now k nearest neighbors is going to basically go to a majority vote based on the neighbors. Okay, in this case, all 3 neighbors are plus. So this is 100% a plus class, right? So if 2 neighbors were red, okay, if 2 neighbors were red and then one was black red dot, then we still classify is a plus. Okay, so with a bit less confidence, not due to the nature of the word, you want to use an odd number for the k. Otherwise, you will find yourself in a 50-50 split situation. So this will be a problem here. So guys, there are ways to apply the weights to the distance. Okay, so to penalize the more for greater distances. So then you could have a number for the k if you wanted. Okay, so anyway guys, that's all for this video. I hope you liked this video and thank you for watching this video, and I will see you in the next tutorial. Thanks for watching. Thank you. Bye bye.